Hello, Mr. Collier here. Today we're going to talk about projectile motion. This is the beginning of a new chapter for us. And our subheading here is, wait, I can move in two directions at once? So far this year, everything we've been talking about has been in one dimension at a time. We talked about motion in the x direction as we started our kinematics chapter, and then we talked about movement in the y direction as we wrapped that chapter up. Today we're going to start putting those together to understand projectiles. So, we've already talked about horizontal motion, motion in the x direction. We can talk about how fast something used to be going, how fast it's going at the end, whether it's accelerating, how long that acceleration took, and when we talk about its movement, we talk about how far it moved in terms of delta x because we're looking at the x-axis. We also talked about motion in the y direction, which has many of the same variables, how fast it's going before and after, how long it's been falling. We switched acceleration out. We still have acceleration, but now acceleration is a fixed number because gravity is what accelerates things in the y direction. And instead of a delta x, we use delta y because, again, we're talking about a different axis. Now, all of that's review, and what we're going to be doing is now putting it together. So what happens if you move in both the x and y direction at the same time? This is what we call a projectile, and it moves a little something like this. Projectiles are going to follow what we call a parabola. So they're going to move with an arc, with a curve through space. We're going to study in this chapter in much more detail the math of that motion. So something to remember when you have motion in both the vertical and horizontal axis is that their motions are actually going to combine, and that's what we're going to be studying. You're going to have some initial velocity in the y direction, some initial velocity in the x direction, and we can look at them independently or together to understand the projectile motion. So let's start looking at some simple examples to understand what assumptions and what premises are going to be part of this chapter. So here's an object in free fall. Its initial velocity in both the x and y direction are 0, and as it falls, it accelerates in the y direction. But what would happen if we launch it horizontally, right? We know now this would be like picture there's a table that it's sitting on and we're going to push it off, right? It's going to fall, but it's also going to move to the right. A horizontal launch is kind of the simplest starting point to talking about projectile motion because the y velocity, the up and down velocity, is only affected by gravity, and then it's also moving in the x direction. So to understand this projectile motion a little better, let's look at what would happen if we launch a ball just horizontally, that's the ball on the left, and drop a ball, that's the ball on the right, from the same height at the same time. What we find is that they hit the ground at the same time. So it takes them the same amount of time to complete their fall. This is going to be an important piece of the puzzle as we study this, and so we're actually going to do several demonstrations of this in class so you can see it not just with an illustration. And what this proves, and you're going to see a lot of these demonstrations, is that horizontal and vertical motions are independent of each other. So whatever the projectile is doing in the horizontal does not affect what it's doing in the vertical. In other words, vertically, it just falls. And horizontally, it just moves left and right. And they combine to give you that projectile motion. But, and this is important to remember, both motions have to occur in the same amount of time because while it's moving left and right, it's also falling. So the total amount of time for the x and the y direction motion is consistent. The next question that we need to consider is, as it launches horizontally, does the velocity in the x direction change? And what we find is that it doesn't. The Vx is constant. There's no acceleration in the x direction. It accelerates vertically because it's falling. Gravity is accelerating it downward, but its velocity, once you let go of a projectile, is just going to be constant. So in review, the key points for understanding projectile motion are understanding that the horizontal motion and vertical motion are independent of each other. What that means is that the object is always accelerating at negative 9.8 meters per second in the vertical direction, and it's going to move at a constant speed in the horizontal direction because you gave it some sort of initial push to the left or to the right. The horizontal and vertical motion are going to take the same amount of time. So if you know anything about time, it's the same in the x and the y. And we're always going to assume that the acceleration in the x direction is 0. There's no air resistance. Once a projectile starts moving in the x direction, nothing is going to speed it up or slow it down in the x direction. Only gravity is going to act on it, and that's only in the y direction. So there's your introduction to projectiles. Good luck.